Hello everyone, my name is Alexander Zelenin and I am experienced software engineer. Today we will solve two lowercase tasks from leetcode with JavaScript. The plan for today: first, inspect the task itself and see what the problems is possible to have here. Second, design an algorithm itself. Third, calculate complexity. Fourth, implement this algorithm. First, we need to think, can we optimize the complexity somehow? Fifth, implement algorithm itself. Sixth is to test that everything fine. And seventh is to see what findings we have during solving the problem. So let's go to lowercase problem and see what we have here. So implement function to lowercase that has a string, return the same string in lowercase. Okay, we have some string and we need to return small string. Yes, it is. So originally in JavaScript you can do this with just one single function and it will be efficient enough. But I think it will be not so interesting. We will do this solution, but we will also explore what other possibilities for solving this task without base function we have. Otherwise it's like super simple. So let's start with the first sorry, I just think that it's funny since the task is super simple. So we have some string and what we need to do: we go from left to right and check is the symbol is on uppercase. How to check that symbol on uppercase? It's not as easy as it looks like, but also it's not complicated. I will explain a bit later. So we check, is it upper or lowercase? If this is uppercase, we modify it and then we go to the next symbol. The problem with strings is JavaScript that they are immutable. What does it mean? Originally, strings, so you cannot just change a string. When you try to modify string somehow, for example, you replace one letter with another, JavaScript underneath will go through all the symbol in your string and will copy every symbol to new string and replace one with the required one. So instead of having super cheap operation of replacing one symbol, you originally make copy of all symbols. So instead of like one operation, we will have like 1, 2, 3, 4, 5 operation for one word. And if we have like 5 symbols, if all of them will be like uppercase, we'll end up with like 25 operation, which is n square, what is totally not nice. We want to avoid such things. We want to solve this task under on. So let's start with the built-in JavaScript function to solve this task. So we have our string and we have function that call to lowercase. Done. Hardest task ever. So success, Okay, everything is fine, everything is great, work great, but as I told, this is not interesting, so we will go for a solution like we doesn't have built-in function. So you will do the same for another languages, or if there will be different condition. So first question, how to determine that symbol is uppercase? We need to understand what is symbol at all. So we have table like this. This is ASCII table. This is like 128 symbols that basically have like every computer, and every symbol have its own code. If you're using different charset, for example UTF-8, UTF-8 have more than 65,000 symbols, but anyway, every of these symbols have a code. And let me put it in Paint. And what is interesting here, what interesting finding we can see here is relations between uppercase and lowercase. You can see that on this table they especially put it like in one line, so from A to Z, all of them in one line. So we have code for small a of 97, and for big one is 65. And for every next letter, we have like the same difference between them. So it's like, so we need to change the upper one to lower one. So it will be like 97 minus 65. So we will need to add 32 to our char code to create a symbol. So the idea is next. We will go from left to right. We take a look at our letter. We take a look at code of this letter, that it's between 65 and 90, including both of them. If it's so, we will find a proper letter to replace. So for H, it will be 104. So we just add 32 to the code and find the proper code of new letter. So we got H, and then we have a couple of options. First of option is to replace it in initial string, which can give us n square, or we can create a new string by creating array initially and then just join this array. So we will do something like that. We will fill the array with all the letters, and like what is not good in this solution comparing to the default one is that we will consume additional ON memory. And the complexity of this should be at least, we go through all the symbols, so it have at least ON space complexity is how memory change depending on incoming variables. So if we have longer string, we will need to store more information the same as string length, so we have ON. Time complexity is how CPU usage change over time depending on incoming variables. So if we have longer string, we will need to do like the same as amount of symbols operations. So it's like linear complexity. So for every letter, the finding is cheap. It's just one function. pushing to array is cheap, and then joining array is also on. So at the end we have on complexity. Let's try to implement our algorithm like with manual way. So we will do it like this. First we create a resulting array, then we will return it. And in the middle, what we need to do is go through all the symbols. So we create a cycle from first symbol to last one. And for every symbol, we will do something like char code will equal to let's have a current char first. So current char will be equal to string I. So we took the element. Then to get the char code, we have a method called get. There is no auto completion, and I didn't remember the exact name for the function. So I will take a look here. What we have: get char code add. Yep. So we have char code add method. Char code. Let me just skip a bit to have like this char code add. So we got our char code, and now we will test that this char code is between 65 and 90. 65 and char code less or equal 90. In this case, we will modify the current char. Maybe we can use let, since we will modify this variable, and we will put it to result. Current char. Okay, so if it like that, then we need to get a char. So we'll take like char code plus 32, but now we need to convert this to symbol itself, and I also didn't remember how to do this. So var test equal a char add just return. What if we have like 65? 1 second. 65. We have method called from char code. Nice. Generally, you can find such things in Google. I just remind some things how it should be, so it's faster to take a look at the console and to play a bit. So we have method called from char code, and we will replace our current symbol with this one. So we just add the two current char code 32 as we found in ASCII table. And then we join everything. So let's try to run our code and see that our output is exactly the same as expected. Let's submit our code. So success, everything is fine, but this one looks like it works slower. But it was expected. Like, we consume more memory and we use more runtime since we do all operations manually. Of course, much better to use some default function, but just in case it's not available in another language, for example, you're solving it's not with JavaScript, the approach will be the same. You have the same ASCII table, you have the same codes, and so on. So let's think what, first of all, we need to calculate our space and time complexity. Set on pause, try to calculate by your own. And let's start. So for space complexity, we're storing only one array, and that's all. All of this is just variables, temporary one that replace it on every cycle. So, and the result will be the same length of string, so it will be on, as it was presumed initially. For the time complexity, we're creating an array. It's 1, it's like a cheap operation. We're going through all symbols, so it will be on. We getting current symbol, it's 1. We getting code of this symbol, it's again 1. Simple condition is 1. Changing variable to another one is 1. And pushing is also 1. So at the end we have on complexity. There is also join that also on, so total complexity should be like 2n, but we can drop constants and we have on. We can drop constants because they are meaningless. Maybe I will create a separate video for explaining how this works and what is meaningful, what is not. So what interesting findings we have during this task? Interesting findings can be regarding the ASCII table itself, that we can like move from one symbol to another with just add the number of 32 if we want to go from lowercase to uppercase, we can do like minus operation, minus 32. If we need to move from uppercase to lowercase, we just do plus 32. That's all. That's all. So set like, subscribe, and I will start next video in few minutes.